Hello, welcome back to JD Science Prep. Today we are discussing limiting reagents within stoichiometry. So, in a chemical reaction, there's usually something called a limiting reagent, and this is when there's not enough of one reactant to fully react with the other. So basically, there's one reactant that will limit the whole reaction, and there's going to be excess of that other reactant. Okay, so if this video helps, please like and subscribe. So basically, there are 5 rules we can follow to find the limiting reagent within a reaction. So first off, like all stoichiometry problems, we will balance the reaction. Number 2, we have to choose a product to find the amount produced with each reactant. So number 3, determine the amount of your chosen product made with one of the reactants. Number 4, determine the amount of your chosen product made with the other reactant. And number 5, the reactant that made less of your chosen product is your limiting reactant. Okay, so we have one example in this video. Let's go through it. So it says if we combine 3 grams of zinc with 3 grams of hydrochloric acid, what will be the limiting reagent? What volume of hydrogen gas will be made, and how much excess will be left over. Okay, so again, step 1 is to just balance this reaction. Okay, so again, if you are having trouble with balancing reactions, I encourage you to go take a look at my video on that. If you are okay with it, this should all make sense. Okay, so step 2, if we scroll on up really quick, it says to choose the product to find the amount produced. So let's take a look at our reaction. And our 2 options, we have zinc chloride and hydrogen gas. I'm going to go ahead and pick hydrogen gas. You could pick zinc chloride, that would be fine. But in this video, I will pick hydrogen gas. So step 3, determine the amount of your chosen product made with one of the reactants. Okay, so we're going to do both reactants. So why don't we just start with zinc? So it says 3 grams of zinc. So, and we want to figure out how many moles of hydrogen gas can be made with 3 grams of zinc. And just quickly, I'm going to scroll over to our stoichiometry flow chart if you're having a little bit of a few problems with figuring out our path. So if you want to pause the video and study this, go ahead. But basically what we are going from is mass of A to moles of B. So it's going to be a 2-step conversion here. So let's get back to this. So first off, we're going from grams or mass of zinc to first moles of zinc. So we'll put moles of zinc on top, and we have to divide by the molar mass, which for zinc is 65.39 grams of zinc. And we are going to have one more conversion here. Remember, when we are going from moles of one substance to moles of another, this is where we are using our balanced coefficients. Okay, so if we want moles of hydrogen, we're going to use that 1 mole of H2 from our balanced equation, and we're getting rid of moles of zinc. Okay, so with this conversion here, we are figuring out the amount of moles of hydrogen being produced from 3 grams of zinc. So we will type into our calculator 3 grams of zinc divided by 65.39. And because we have a 1-to-1 ratio in our mole-to-mole step, we don't have to really do anything. So when you type that into your calculator, you should get 0.04588 moles of hydrogen. Okay. All right, so that is step 3. Let's move on to step 4, which is pretty much the exact same thing, but with our other reactant. Okay, so now we're going to be looking at our hydrochloric acid. So we have, again, 3 grams of HCl, And first we are going to moles of HCl. So we have moles of HCl on top, and we are dividing by our molar mass of HCl. And now we have to go from moles of HCl to moles of hydrogen gas. So again, we're using those balanced coefficients from our balanced equation. So we'll go 1 mole of H2 on top, and on the bottom we are putting 2 moles of HCl. Okay, so now we can type this into our calculator. We have 3 grams divided by 36.46, and that's divided by 2 because we have that 1/2 ratio in our mole to mole step. So we have 0.04114 moles of H2 produced from 3 grams of HCl. So because the 3 grams of HCl created less H2, we're going to say that 3 grams of hydrochloric acid is our limiting reagent. So just quickly, because the question didn't ask for how many moles of H2 is being produced, it just asked for the limiting reagent. We don't really have to worry about sig figs in this step. Okay, but when it asks for the volume of hydrogen gas, that's where we're going to bring sig figs into account, as well as the very last part of this question, how much excess will be left over. So let's get into the volume of hydrogen gas produced. So because we know that 3 grams of HCl is our limiting reagent, we can just go from the amount of hydrogen gas produced by our limiting reagent to the volume of H2. And then that's just going to be a one-step conversion. So let's go ahead and do that right now. So we have 0.04114 moles of H2, and we are converting to volume. So again, if you want to go back to the part in the video with the flow chart, you will find that in order to go from moles to volume, we are putting that gas constant on top, and we're just dividing by the mole, or 1 mole of H2. Okay, because remember, 22.4 liters equals 1 mole always. Okay, especially or only for gases. All right, so now we just divide 0.04114, or sorry, we multiply it by 22.4, and that's going to give us our answer. So you should get an answer of 0.92 liters of H2, and those sig figs look very good. We had 2 in our question, so we're just going to keep 2 in our answer. And now the very last part of our question, it asks how much excess is left over. So students tend to get mixed up on this part a little bit, but as long as you can memorize where to start and where you're going to end, it should be okay. All right. So basically, we have to start with our limiting reagent, which we know is the 3 grams of hydrochloric acid. And with that, we're going to move from, actually, I'll write it down. So grams of limiting reagent, and we want to eventually get to grams of our excess reagent. Okay, and once we have the grams of excess reagent, what this finds is how much is used, and if we want to find the amount that is left over, we just subtract our original amount, subtract our amount used, and that's going to get us our answer. So stay tuned here. Let's get through this. So we know our LR is 3 grams of HCl, and we're just going to get 2 moles of HCl. So we have 1 mole of HCl on top, and that's divided by our molar mass, which is 36.46 grams of HCl. Now we want to get to moles of our excess. Moles of excess, which was our zinc. So we have 1 mole of zinc, and remember from our balanced equation, so 1 mole of zinc and 2 moles of HCl. So our 2 moles of HCl will be on the bottom. And finally, we want to get to mass of zinc. So we'll just multiply this by our molar mass of zinc, which is 65.39 grams of zinc. And that's all over moles of zinc. And let's just check if our units cross off. They should. Looks good to me. We're going to be left with grams of zinc. So let's throw this into our calculator and let's get a calculation. So 3 divided by 36.46 divided by 2 multiplied by 65.39. And what you should get is 2.69 grams of zinc. And what that represents is the amount of zinc used. So the amount of zinc used. And since the question wants us to find the amount that is left over, all we have to do is take our original amount of zinc, so 3 grams of zinc is what we started with, subtract 2.69 grams of zinc that was used, and that's going to get us how much zinc is left over. So 3 minus 2.69 equals 0.31 grams of zinc left over. So again, that is limiting reagents. I hope this video has helped. Please like and subscribe.